Now we discuss about regressions. What are regression lines? Lines y on x and the lines x on y. So what does it mean by the regression line y on x and x on y? So let me define, check on the screen, just like we are explaining that regression lines y on x. So the first line is the regression line, which is y on x. Okay, so this line is actually that line which is used. Okay, this is the line which is used to find, of course we will find x or y. So the first variable is x and the second variable is y. So the line used to find y when x is given, this is the regression line y on x. Okay, and when we talk about the x on y line, then this means that this is again another line just like y on x line. It is similar to x on y line, which means that this is another line which is used to find x, when y is given. Okay, so these are the lines, regression lines, when regression lines x on y and the regression lines y on x. Okay, so after defining regression lines, we will move to the sum points. Okay, just like we will take sum points x1, x2, x3, x4 up to so on xn, and the corresponding value of these points are y1, y2, y3 and up to so on yn. Okay, so actually regression is the relation between the two variables. The first variable is x and the second variable is y, and these variables depend on each other. Regression lines when y on x. So what is the regression line y on? Okay, we will define it just like as it is y minus y prime, y minus y dash, which is equal to okay, b into byx is equal to x minus x bar. It is not dash, it is x minus x bar, y minus y bar, x minus x bar. Actually it is the x bar and y bar are the arithmetic means. Remember that here x bar means arithmetic means of all the values of x, and y bar means that arithmetic mean of all the values of y. Okay, and similarly we can find the regression lines y on x. Okay, as we have already defined that what is the regression line y on x, it is y minus y bar, which is equal to byx, x minus x bar. In the similar fashion we can find the regression line x on y, which is defined as x minus x bar. Remember that when it is x on y, regression line on x on y, then it will be x minus x bar, which is equal to bxy. I am not writing on the screen, actually I am taking the voiceover. Okay, so that equation will be just like x minus x bar is equal to byx. No, not byx, it is bxy into x minus x bar. It's okay. Once again check that what will be the regression line x on y. It will be x minus x bar, which is equal to bxy into y minus y bar. Okay, so where bxy is the regression coefficient. Okay, regression coefficient, bxy is the regression coefficient, also byx is also the regression coefficient. Okay, so when we talk about the bxy, this is the regression coefficient when regression coefficient of x on y, and by means that this is the regression coefficient y on x. Okay, so x bar can also be written as, it is of course, as I have already explained, that x bar means that it is the arithmetic mean summation x divided by n, and y bar mean is equal to summation y divided by n. All we will add all the values of x divided by the total values, all the values of y divided by the total values. Okay, so after defining the regression lines y on x and the regression line x and y, and as we have already explained that bxy or bxy or bxy, these are the regression coefficients on x on y and y on x respectively. Okay, so let me move a little bit next to understand the phenomena of regression lines. Okay, so in this chapter of regression analysis, you will all understand about the regression lines, regression coefficients. Okay, so now we are talking about the regression coefficients. What are the regressions coefficient? And the regression coefficients are just like we will define over here. It is bxy is equal to regression coefficient is equal to rho. What we are talking over here, rho sigma y divided by sigma x, and in the similar way this can be equal to rho sigma y divided by sigma x is equal to summation xy minus summation x summation y divided by n, and whole divided by it is yes, summation y minus summation y square minus summation y whole square. Okay, remember that this is summation y whole square divided by n. Okay, and in the similar way we can write the regression coefficient bxy, since this is the regression coefficient byx, and now we will write the regression coefficient bxy. Okay, yes, regression coefficient bxy. But in order to define this, first we will show that what is sigma y over here. The value of sigma y is equal to yes, this is equal to sigma y is equal to summation y minus y bar square, and it is divided by n. Okay, this is the value of sigma y, and similarly the value of sigma x is equal to x minus x bar, okay, whole square summation divided by n. Okay, the regression coefficient byx, now n. Okay, the regression coefficient byx, now we will talk about the regression coefficient bxy. Okay, let me write. Similarly, it is bxy. Remember that we are writing over here bxy, which is equal to summation. Now it is rho sigma x divided by sigma y, which is equal to summation. It is xy, summation xy minus summation x and summation y divided by n, and divided by this is equal to summation. Since we are talking about sigma xy, therefore we will write sigma summation y square minus summation y whole square divided by n. So these are the byx and bxy. It look like it is sigma xy, but remember over that it is bxy. Okay, so these are byx and bxy are the regression coefficient. Okay, in the similar way as we have already described that what is sigma y and what is sigma x, what are the values of sigma y and sigma x. Okay, so let me take another approach. The other approach is we will take u is equal to x minus a and v is equal to x minus b. Okay, so where what does it mean by a and b? A and b are actually the assumed means. Assumed means that we will when our data is given, then we will assume the values. okay, and that value will be, you can assume that just, which means that it is not necessary or there is not any certain conditions, or you are not to force to choose the some specific value. Assumed value means that a and b are the assumed values, not the specific values. It is simple, okay. So here we are writing that a is equal to assumed mean of x and b is equal to assumed mean of y, okay. Hope you have understand that what does it mean by, okay. But in the previous in the previous approach, this is new approach, in the previous approach we have used row, okay. And here I would like to explain that what does it. Rho is the coefficient of it is coefficient of correlation, coefficient of correlation, okay. In our new approach, when we are taking u is equal to x minus a and v is equal to x minus b, then what will be the regression coefficients means bxy and byx. So when we talk about bxy, the formula for this is bxy is equal to summation ub minus summation u summation v divided by n, and divided by, it is summation u square, it is summation v square minus summation v whole square, okay. We will take summation v whole square divided by n, okay. This is bxy, okay. Now we take byx. When we take byx, the formula will be just like as summation u and summation v minus summation x summation y divided by n, and divided by summation v square, okay, summation u square. Over here we write summation u square minus summation u whole square divided by n, okay. Now we discuss the certain properties of regressions. The first property of regression is regression lines always intersect at certain points, and that certain points are x bar comma y bar. As I have already explained that what does it mean by x bar and y bar. X bar and y bar means it is the arithmetic means of all the value of x and y respectively, okay. So regression lines always intersect at the point, and what is that point? That point is x bar comma y bar, okay. This is the first property of regressions. And the second property of regression is if the lines, if two regression lines, okay, if two regression lines yes, if two regression lines are given, okay, how many regression lines? Two regression lines are given, and we suppose that theta is the angle between the two regression lines, okay. If theta is the angle between two regression lines, then it means that of course it will be given, and these angles, remember that this angle is an acute angle, not obtuse angles, okay. The regression lines, two lines, how many lines? There are two lines which are regression lines, and theta is an acute angle between them. If theta is the acute angle between them, then what will be the value of tan theta? Then show that actually we want to prove this property. Over here we will prove this property. What we will prove? We will prove that tan theta is equal to, it is 1 minus rho square, 1 minus rho square divided by rho absolute value, okay. And the absolute value of it is sigma x minus sigma y divided by, it is sigma x square plus sigma y square, okay, and its absolute value. Okay, so these are two absolute value that we want to prove. So this property, in order to prove this property, of course we will use the regression lines, as we have already discussed before. What are the regression lines? What are the value of sigma x? What is the value of sigma y? What is the value of bxy? What is the value of byx? By using these results we will prove it. Okay, so here what does it mean by rho? As we have already talking about rho, it is the coefficient of correlation. Okay, so let me take the approach to prove this. So regression lines uh, regression lines x and y, and the regression lines y on x we will use to prove this property. Okay, so the regression lines is y minus y bar, which is equal to rho into, it is sigma y divided by sigma x. Okay, and it is equal to x minus x bar, and minus, it is, no, not minus, it is equal to 1. This is 1. Okay, so we have used the formula over here. X minus x bar is equal to rho sigma x divided by sigma y, which is x minus, it is y minus, so this is the first is the regression line x on y, and this is the regression line y on x. So let this is 2. Okay, and remember that the value of bxy and byx has also described over here, which is rho sigma y over sigma x, rho sigma x and sigma y respectively. Okay, where m1 is equal to gradient means slope. Okay, slope of the lines, slope of the regression lines. Okay, so m1 is the slope of line, or which line? The first lines x on y. Okay, and m2 is the slope of the second line. Okay, y on x, x on y and y on x. So this is gradient of line 2. So we are taking over here gradient or slope of two lines. Okay, the first line and the second lines. As I have already explained that in order to prove regressions, in order to prove this property tan theta is equal to something, we will use the regression lines. Okay, so we have written over here two regression lines. Since we have written the two regression lines, this implies that from 1 we can write m1 is equal to rho, which is sigma y and sigma x, from equation 1, and from equation 2 we can write m2, which is equal to rho. Okay, it will be, which is equal to rho 1 over rho. Remember that 1 over rho. Okay, actually we want to convert it into y is equal to mx plus c. Okay, where m is the gradient. Remember that y is equal to mx plus c. When we convert it into y is equal to mx plus c, which is a linear regression, remember that y is equal to mx plus c is a linear regressions. Okay, so here m is the gradient. Okay, when we find y is equal to mx plus c, you can see that the first line is already is in y is equal to something. So we can write just like m1 is equal to rho into sigma y over sigma x, and the second line is not, it is actually x is equal to. So when we convert the second line, which is the line of regressions, y is equal to something, then what it will be, we will find that our gradient, our slope will be equal to 1 over m, 1 over rho and sigma y over sigma x. As I have already explained that we will compare it y is equal to mx plus c. Okay, which is the equation of a straight line or equation of regressions. Okay, it is also called linear regression. Okay, as we already know that tan theta is equal to m1 minus m2 divided by 1 plus m1 into m2. Okay, so we will put the value of m1 and m2 that we have already from the lines of regressions. Okay, so what is the value of m1? After putting the value of m1, we will get the form just like as the first value, which is m1. When we put, it will be rho sigma y sigma x, and the value of m2 is 1 over rho, and this is sigma y divided by sigma x, and divided by, of course, yes, it is absolute value, divided by 1 plus rho and sigma y divided by sigma x. Yes, and the value of m2 is, it is 1 over rho, and this is sigma y divided by sigma x, and this is equal to rho minus, because we are taking common over here. So what we are taking common? We are taking sigma y over sigma x from the numerator common. Okay, and here we left only rho minus 1 over rho. Okay, and sigma y and sigma x is common, just like over here. Similarly, in the denominator, we can write sigma x square plus sigma y square divided by sigma x square, and this is equal to rho square minus 1 divided by rho, and after converting it, we will simplify it. We will get just like sigma x minus sigma y divided by sigma x square plus sigma y square, and we have proved this result. Okay, so this was the second property that we have proved over here. When rho is equal to 0, which means that theta is equal to pi by 2. So what does it mean by theta is equal to 0 or theta is equal to pi by 2? Theta is equal to 0 means that the regression lines are parallel, and when theta is equal to pi by 2, which means that regression lines are perpendicular to each other. It's okay. Hope you have understand up to over here. This is the second property, and now we move to the third property. The third property is the coefficient of correlation is geometric mean of regression coefficient, which means that coefficient of correlation is the geometric mean of regression. So bxy is equal to sigma x divided by sigma y, and byx is equal to rho sigma y sigma x, where the geometric mean is equal to, always we write it is square root of AB. So it is byx and bxy is equal to rho sigma x and sigma y, and the value of bxy is rho sigma y sigma x, and here you can see that we get only rho square, which is equal to rho, which means that geometric mean is equal to coefficient of correlation, where rho is the coefficient of correlation. It's okay. If our regression coefficient is greater than 1, if our regression coefficient is greater than 1, then other should be less than 1. Okay, or if our regression coefficient is less than 1, then the other should be greater than 1. Now rho is equal to byx, and it is bxy divided by, yes, geometric mean. So rho square is equal to byx and bxy, and since as we know that rho is always in between -1 and 1, therefore rho square is always between 0 and 1 after taking square. Okay, so this means that from here we can conclude that since rho square is always less than or equal to 1, this implies that bxy byx is always less than or equal to 1, and this means that bxy is less than 1 if byx is greater than 1. Okay, because the above inequality always hold when one value is greater and other value is. So now there is a question. So